This is next part of introduction to real analysis. It's called algebraic structures. So today we are looking about on algebraic structures. This is the Vika Academy. Please subscribe if you have not subscribed. Again, share with your friends if you have subscribed. Now, if we let positive or addition sign and the star sign denote addition and multiplications respectively, then we come up with given laws that govern real analysis, not only real analysis but different parts of abstract mathematics. You will be able to apply these laws, so you need to keep them in your mind and always refresh them when you need them. So we have first law is called closure law, whereby if you have given elements of R, if you sum them or you multiply them or you apply the given application or addition, you'll find the solution is still in R. When you find the solution is still in R, you see that is closure. It's closure. For example, we know that 1, 2, 3 is they are real numbers, so they belong to real numbers class set. Now if you have 1 plus 2, you get 3. Is 3 in R? Yes. When you do 1 times 2, do you get 2? You get 2. Is 2 in R? So you get 2 is in R. So that is called closure law. The next law is called commutativity law, and it says if you have x and y in R in real set, it doesn't matter the arrangement of the addition. So if you do x plus y will be same as y plus x, you get the same solution. If you apply a multiplication, you do x star y will be equal to the same as y star x. That is called commutativity law. The next law is called associativity law. If you have x, y, z members of R and you find that x plus y plus z, and you group, like first you do y plus z, and the solution that you get, say solution P, you do x plus P, it will be same as doing x y, which is maybe Q plus z. So the solution will be same. So it doesn't matter the arrangement of addition or application of multiplication. That gives you similar or actually same solution, and that is called associativity law. Next, we have identity law. Identity law states that there exists a distinct element 0 for addition and 1 for multiplication, on which if you take an element in R, say x, you want it to 0, and you apply the idea of commutativity, you also get same solution. My online. Oh, okay, universe law. So if you have a x in a real set and y in a real set, x star y will be same as s star x, which gives you 1. That is an addition. And then we have x plus y being equal to y plus x and addition. So in this case, x is the inverse of y. X is the inverse of y. So it doesn't matter the arrangements. The next one is distributive law. Whereby if you have x, y, z in real numbers, if you do multiplication of x star y plus z, you can open in this arrangement, in that arrangement, and therefore we have this. So that is basically distributive law. Okay, so what have you looked at? We have looked at number 1, closure law, number 2, commutativity law, number 3, associativity law, number 4, identity law, number 5, inverse law, and number 6, distributive law. So those are the key laws in real analysis. So if you have a question on this, kindly leave a comment. Just leave a comment. Okay, so if you have a set S with the same operations, that is positive and the star, and the above laws owned, if the above laws owned, the one that we have just discussed right now, we call that particular S field. Now, S is called order and field if this ordering relationship is applicable. It's applicable. And therefore, the following axioms hold that if you have a given x in that set, can be S or F, which is a field in this case, x is greater or equal to x, or in other words, x relates to x, what we call reflexive. We call reflexive axiom. Reflexive axiom. Then if you have x and y for this given set, and define x is less than or equal to y, and y is less or equal to x, what does that imply? It implies that x and y then must be equal. So that we call it symmetry. We call that one symmetry. Yeah, symmetry. Okay. Again, if we have x being greater or equal to y and y being greater or equal to z, then this relationship, it will imply that x is less or equal to is greater or equal to z, and this kind of law we call it transitive law. We call it transitive law. Now, those three are the key basic axioms. The other two are based on the three main field axioms: reflexive, symmetry, and transitive. Let's look at 4. If you stand 4 well, we are taking the symmetry sign where x is the transitive sign. If we have x plus z will be greater than or equal to y plus z. This is basically from here. Yes, just basically from there. Then, if we take x to be greater or subtending y, and x is greater or equal to 0, then x by z will be greater or equal to y star z, which is basically this 4 and this. They are basically applying same thing. So we have x being greater or equal to y. So we had z there, x plus z, that becomes true. And if you are applying multiplication, it will mean this is also true. And this is basically the 5 key axioms for field. The key, so reflexive, symmetry, transitive, and the addition and modification of that. So that if A satisfies the above axioms, then we call that as an ordered field. So if you are told to test for ordered field, you need to confirm whether the 5 axioms befits the or satisfy the given set. So if you have a question on nth of the point, you can leave a comment. If you have a question that you need me to tackle, leave the question. We'll be able to look at it. Kindly subscribe and share. Thank you. Until next time.